Question 6. Which option correctly identifies the voltage and frequency of the Australian domestic power supply? That is the power supply in houses. Is it 115 volts at 50 Hz, 115 volts at 60 Hz, 240 volts at 50 Hz, or 240 volts at 60 Hz? Now, because this will vary from country to country, I'm sure you'd be able to find, if you look carefully enough, countries that use any one of these combinations. The one that we use in Australia, though, is C, 240 volts at a frequency of 50 Hz. Question 7. A power socket's wired in parallel or in series with each other. How can you tell? Now this one shouldn't be too hard, should it? They're wired in parallel with each other, because if one is disconnected, current will still flow through the others. If they were in series, as soon as current stopped flowing through one power circuit, that is, as soon as you unplug something from it, then current would have to stop flowing through the rest of the power sockets. So in reality, we just wire them all in parallel. It means that we can unplug things without worrying about the others. Part B. Are fuses wired in parallel or in series with their respective circuits? How can you tell? Now, what is a fuse? A fuse is a device that stops current flowing through it permanently if the current through it gets too large. And when this happens, it stops the current flowing through whatever it's connected to. So they must be wired in series, because once the fuse is blown, current stops flowing through the circuit. If the fuse was wired in parallel, this wouldn't happen. Question 8. Describe the purpose of the active wire. So what does the active wire do? Remember that we have two wires leading from the distribution transformer to our house. One is the active wire and one is the neutral wire. So the active wire has an alternating potential so that it produces a current when it's connected to the neutral wire. And so what's the purpose of the neutral wire? Well, the neutral wire is fixed at a potential of plus 0 volts. That means there's always a voltage between the active wire and the neutral wire. And so a current can run through the neutral wire when it's connected to the active wire. Finally, describe the purpose of the earth wire, the third electrical contact. Can you remember what it is? Well, it doesn't carry current in or out of the circuit, but it protects against electric shocks. The earth wire is connected to the ground, and it prevents metal casings from becoming dangerous in the event that a fault causes the active wire to touch the casing. Now, if the active wire did touch the casing, and you were to accidentally touch the outside of the electric device, then the difference in potential between the casing and the floor could cause an electrical current to flow through you as soon as you touch the casing, and this would cause an electric shock. Question 9. Of the three contacts in an electrical socket, which would be the least dangerous to stick a fork into? I'd just like to point out that it is a very stupid idea to stick anything metal into an electrical power socket, not least because it could be electrocuted. Even if you chose the least dangerous part of the electrical socket, you could damage the socket, or you could cause a fault within the socket that causes you to become electrocuted anyway. Or you could convince others to try and do the same thing. So the correct answer is that the bottom vertically oriented contact, in the Australian power sockets at least, would be the safest because this is the earth contact, or the ground contact. The fork is, hopefully, already at a neutral potential, the same potential as the ground or the earth. So when it's put into the power socket, there's no potential difference, that is, no voltage, between the bottom part, the bottom contact rather, and the fork itself. So there's no voltage between them and no current flows. Assuming, of course, you don't cause the contact to malfunction by sticking something into it. So no current will flow between the fork and the earth wire. Once again, don't try this at home. Only a fool would do that. Question 10. Why are fuses important? So remember that a fuse is a safety device that prevents electrical current flowing through a circuit. When large amounts of current flow through a circuit, the circuit radiates a large amount of power. Thinking back, we can remember our equation for power loss, I squared R. Now, if we have an electrical fault in the circuit, which causes a very, very large amount of current, what will happen to the resistors of that circuit? Well, the power can damage or destroy the electrical component that through which the current is flowing, right? Power means that a lot of energy is being radiated as heat, and if there's lots and lots of heat, that means high temperatures, which can damage electrical components. So a fuse is useful because it prevents the current from becoming large enough to cause this sort of damage. So that's the end of the questions. In this section, we've learned about household wiring and the 3 parallel circuits that are connected to the power supply of a house: the lighting circuit, the power circuit, and special circuits for high-powered devices. We've also looked at some of the safety devices that we use in our house.